Good morning, dear students. So, from today onwards, we are starting a new chapter, that is chapter number 8 in calculus, which is integrals. Okay? And the process of solving in integrals is called integration. Here we'll learn two types of integrals. One is indefinite integrals and the other one is definite integrals. Now, indefinite integrals, they have 13 to 14 exercises that we have to learn, and then definite integrals later. Okay? So before that, let us understand something about integrals. What are the symbols for integrals? Okay, so symbol for integral is this symbol for integrals. This represents a symbol for integrals, and I'm integrating this function with respect to x. So hence I have to put this dx. Okay, derivative was d dx, and here it is integrals, means this dx. Okay. And the function out here, this function is called integrand. This function is called integrand, fx. So I'm integrating fx with respect to x. Okay, so before we start the exercise out here, let's go to the formulas. Basic formulas. These are the standard integrals. Okay, integration x to the power n dx is equals to, the power gets added, x to the power n plus 1 divided by n plus 1. Sorry, the power get increased. In differentiation, the power decreases. Integration, the power increases. Actually, integration is the opposite of, or the, differentiation. Opposite of differentiation. Antiderivative. We also call it as antiderivative. Okay. Formula number 1. And here in integration, we have to add plus c. Integration of this means this plus c. This c is called constant of integration. Number 2, integration 1 by x dx is equals to log x. Remember that differentiation of log x was 1 by x. So integration of 1 by x will be log x plus c. Obviously x cannot be equals to 0, because if x equals to 0, then the function is undefined. 1 by 0 will be infinity, isn't it? Okay, x cannot be equals to 0. Here, integration of a to the power x. Remember the formula of differentiation of a to the power x. Differentiation of a to the power x was a to the power x into log a bc, isn't it? And here it will be a to the power x, not into but divided by log a bc plus c. And here a cannot be equals to 0. So please keep these things in your mind. Okay, the formulas are quite similar in integration, differentiation, subtraction, integration, addition. These are the opposite. In differentiation into, in integration divided by, and e to the power x is same as e to the power x. Okay, integration of e to the power x is e to the power x. Differentiation of e to the power x is also e to the power x plus c. Okay, so go through the formulas, pause the video to note down all the formulas you'll get in page number 652. Okay, so let's get back to our work now. Exercise 8.1. The question is evaluate. Okay, evaluate the integrals. Okay, the first integral given to us is integration x to the power 5 dx. Now I have to integrate this. Now in this whole chapter, whenever integral is given to us, we can represent this integral by capital I. So hence I'm assuming let capital I be this integral. Okay, so capital I is this. I need to find the value for capital I. I need to find the value for this capital I. Okay. So this capital I means integration of x to the power 5 dx. So my function out here is x to the power 5. It is in the form of x to the power n. So what was integration of x to the power n? Integration of x to the power n was x to the power n plus 1 divided by n plus 1 plus c. What is the value for n? 5. So hence my integration of this. And when I am using integration now, in the other step, please remove this m dx. Okay, like this. Here there is no dx. No integration sign now. So integration of x to the power n dx will be x to the power n plus 1 divided by n plus 1. So your integration of x to the power 5 will be x to the power 5 plus 1 divided by 5 plus 1 plus c. Just increase the power by 1. 5 plus 1 divided by 5 plus 1 plus 6, which is 6, and plus c. Okay? Pause the video to note down. I move to number 2. Part 2. The question is integration 1 by x cubed dx. 1 by x cubed dx. I don't have direct formula. So hence what we'll do is we can bring this x cubed to the numerator. It becomes x to the power minus 3. And the formula is same. Again, you use the formula of x to the power n. The value for n out here is minus 3. So x to the power minus 3 plus 1 divided by minus 3 plus 1 plus c, which will be this. Pause the video to note down. Okay, question number 1 part 3 same you can do. I'm moving to number 2 part 1. Integration 1 by cube root of x. Now cube root of x means x to the power 1 by 3. Now again what to do? Take this to the numerator, it becomes minus 1 by 3. So the value for n is minus 1 by 3. Use the formula x to the power minus 1 by 3 plus 1 divided by minus 1 by 3 plus 1 plus c. So when you solve it, we get x to the power minus 2 by 3 divided by minus 2 by 3 plus c, which is this. Okay. Next one is question number 3 part 1. Now question number 3 part 1 is integration 5 to the power x into dx. Now what is the formula? The formula is this. Integration of a to the power x dx is a to the power x divided by log a plus c. So what is the value for a out here? 5. So 5 to the power x divided by log 5 plus c. Very simple, straightforward. Use the formula, just putting the value for a as 5. I move to question number 3 part 2. It is integration 7 to the power x into e to the power x dx. Power is x, power is x. So I'm keeping them in the same bracket. So I can write 7e to the power x. See, 7 is also a constant, e is also a constant, so I am keeping them in the same bracket, 7e. So 7e is one constant. E was also a constant, so 7e is also a constant. So use the same formula. Is it in the form of e to the power x? Because this is a constant. So a to the power x divided by log a base e plus c. Okay, the same thing is out here also. Power is x, power is x. I'm keeping them in the same bracket, and the power is x. So again, the same formula. This is a, so a to the power x divided by log a. The value for out here is 4 by 9. Okay, so pause the video to note down. Okay, so next one I am doing question number 5. See, I am not doing number 4 right now because I have not given the formula for trigonometric integrals. Okay, so we can do that later. So application of 4 formulas only we are doing right now. Okay, before doing number 5, one property of logarithm is very important for us to know out here, and the property of that property of logarithm is e to the power log x square or anything out here, but the base has to be e. Okay, so if this base and this number is same, are you understanding my point? If this base and this number is same, then the value for whole logarithm will be this value only, that is x square. But provided the coefficient of logarithm has to be 1, which is 1 out here. So once again, the property is e to the power log of something, and the base of the logarithm and the number has to be same. Here it is e. Suppose the base is 5, here also it has to be 5. Okay, and provided the coefficient of logarithm has to be 1, the value for this whole will be only this x square when the base is same. Okay, are you clear? Let's proceed now. Number 5 part 1. Integration e to the power the power of e is 2 log x into x to the power minus 3. Okay, keep this as it is, but here what I can do is e to the power 2 log x. I can use the property of logarithm out here, not this property here. I can use the property of this property of logarithm. 2 log x means log x square. 2 log x means log x, so the coefficient becomes the power. So here the coefficient becomes the power, which means this. Okay, and now the coefficient of log is 1. Here it was 2, now it is 1 using the property. And now what I know is, if the base is not mentioned, then the base is always e. So base is always e out here. So now base is e and the number is also e out here. So I can use this property, isn't it? So hence using this property, it becomes e to the power log x square. E to the power log x square, the coefficient of log is 1, the base and this number is same. So hence this is only x square. I hope you are clear with this property. So hence this is only x square. So x square into x to the power minus 3 means x to the power minus 1. Because the bases are same, you can add the powers, you get minus 1. So x to the power minus 1 means 1 by x, and integration of 1 by x. What was the formula? It was log x. This was the third formula, isn't it? Integration of log x is equals to 1 by x, third or second formula. So pause the video to note down. Next we move to question number 5 part 2. And here we have integration 5 to the power 2 log x base 5. So here the coefficient of log is not 2. So here the coefficient of log is not, here the coefficient of log is not 1, here the coefficient of log is 2. So what will I do first? I'll make the coefficient of log 1 using the same property. 2 log x means log x square. So this coefficient come as the power. And now the coefficient is 1 and the number is 5. The base is also 5. So hence the value for this whole is only x square. So x square means this. Integration of x square means x to the power 2 plus 1 divided by 2 plus 1, which is x cubed by 3. So pause the video to note down, and please do understand each and every step properly. Please understand each and every step properly. Okay. Okay. Next one would be question number 5 part 3. Integration 2 to the power log x base 4 dx. Already the coefficient of log is 1 out here, but the base and the number is not same. I have to make anyhow this 2 as 4. 4 related with 4. Isn't it? Because here has to be 4, then only I can use that property. So what I can do is, I know 2 means what? Can I write 2 as root over 4? Because root over 4, what is the value for root 4? Root 4 is 2, isn't it? And root 4 also means, is it 4 to the power half? Is it 4 to the power half? So all in all, can I write in place of 2 as 4 to the power half? If I can do that, then let's see what we get. So which means this, I'm replacing 2 by root over 4. Root over 4 means 4 to the power half. Now 4 to the power half log isn't it? So I can use the power half and log gets multiplied. So hence I get the next step, that is this, 4 to the power half log x base 4. Now use the property of logarithm. This coefficient half goes to the power and I get this step, isn't it? Log 4 to the power log x to the power half base 4. The base and the number is same, so hence the value for this is only x to the power half. So x to the power half means this, and integration of x to the power half we know how to do. X to the power half plus 1 divided by half plus 1, which is x to the power 3 by 2 divided by 3 by 2 plus c. From here till here it is not a problem. I'm only hoping that the problem for you all will be this, but to practice it properly, the solution becomes very easy. Okay, so pause the video to note down. Okay, and then this formulas, 4 formulas I've given. Formula number 5, 6, 7, 8, 9 and 10. I want you people to learn it by heart, and this formula we'll be doing tomorrow. The application of this formulas we'll be doing tomorrow. I'll just go through the formulas. Integration of sin x means minus cos x. Integration of cos x means sin x. Integration of sec square x means tan x plus c. Integration of cos x square x minus cot x plus c. Integration of sec x tan x sec x plus c. Integration of cosec x cot x minus cosec x plus c. Please go to the formulas, and here I have not mentioned the formula for tan, integration of tan x, integration of cot x, integration of sec x, integration of cosec x. We are not doing that formula right now, because those will be 4 standard integrals that we'll be doing later. Okay, so this 6 and then 4 becomes total 10 formulas. Very important formulas. Okay, at least for 3-4 exercise. Not only for 3-4 exercise, these formulas are very important. Okay, for integration. So please go through the formulas. So that's it for today, and your assignments will be question number 1 part 3, 2 part 2 and question number 2 part 3, and also to learn the formulas by heart. So that's it for today, and tomorrow we'll be starting with the other exercise. Okay, thank you.